over log 4 is 2 raised to power 2 is 10 minus log 2 raised to 2 log 2 base 10. Now, by that law that says that log m raised to power p is the same thing as p log m, I want to apply it here. This one comes to the back, so I have 3 log 2 base 10 minus 2 log 2 base 10 over, this one also is 2 log 2 base 10 minus log 2 base 10. If you look at this very well, you see that log 2 base 10 is common to them, so I can factorize log 2 base 10 out. Log 2 base 10, if I factorize out of this, I'm left with 3, then here it will be minus 2 over this one. Log 2 base 10 is common, log 2 base 10, then this one will be left with 2 minus, this one will be left with 1. Then I can cancel log 2 base 10, log 2 base 10. So I have 3 minus 2, 1, 1 minus 2, 2 minus 1, 1, 3 minus 2, 1, 2 minus 1, 1, 1 divided by 1, 1. So the answer is 1. So go to our option and check the option that correlates with that. So by so doing, we have the first one here is log 2 base 10, B, 8, log 8 base 10, C, log 0, D, log 4 base 10. Then the option E definitely should be log 1. So 1 rather instead of 1. So in this, if you are given 4 options like this, A, B, C, D, it means there is no correct answer in the options. But if E is included as 1, then option E will be a suitable option for that. So take note of that. Then the next question, that is question 19, which says that log 7 over 3 base A plus 1 over 4 log A base 10 minus 1 over 12 log A raised to power 7 base 10. The question asks us to simplify that. So by simplifying this, I have log 7 over 3 base A plus 1 over 4 log A base 10 minus 1 over 12 log A base 7 and log A raised to power 7 base 10. Question asks us to simplify that. Now to simplify this one remains log 7 over 3 base A plus, this one will now be log A, this one comes here, become 1 over 4 base 10 minus, this one becomes log, this one goes also over A into 1 over 12, then base 10. So we're going to have, then here we're going to have, so we're going to have log, this is log A raised to power 7, this is log A raised to power 7, this one is log 10. So from the question here we have, this is log A base 10. So here we have log A 7 raised to power 3 that I'm having. So in this situation, we are going to have this plus log A raised to power 7 over 3 base 10 and this. You have a common log. So automatically an addition, you are meant to multiply. So A 7 over 3 times A 1 over 4 base 10 minus, this one will become log A 7 times 1 over 12 base 10. So this one will definitely be log A base 10. 7 times 1, 7. 3 times 4, 12. So A raised to power 7 over 12 minus log, this one will now be A 7 times 1, 7 over 12, 10. So in this situation, this and this is more or less like they are the same, just like saying A minus A, what's that? 0. This minus this, we are making 0. go to the option and see the one that correlates to that, and it is option C, which is equals to 0. The next question says, without using tables, find the numerical value of this. So without using table. Now we are given log, that's question 20, log 49 base 7 plus log 1 over 7 base 7. Here, 49 is 7 times 7, so I can write this one as log 7 raised to power 2 is 7 plus this one is log 7 raised to power minus 1 is the same thing as 1 over 7 base 7. Then I transfer this one to this side, I have 2 log 7 is 7. This one becomes, there is a plus here, and minus 1 is coming here, minus 1 log 7 is 7. So this one is 2. Log of the same base is 1, so 2 into 1. Plus times minus minus 1. Log of the same base is 1. So I have 2 times 1, 2. Minus 1 times 1, 1. 2 minus 1. 2 minus 1, 1. So the answer will definitely be 1. So let's see the one that will correlate to that. That's option A. Out of that. Now, question 21, which says that 2 over 3 raised to power m times 3 over 4 raised to power n equals to 256 divided by 729. Now, let's simplify this. So I can write this one as 2 raised to power m over 3 raised to power n times, this one can be written as 3 raised to power n over 4 raised to power n. So at this point, I believe this is very understood, since it has been said in one of the law of indices that when you have a power, when you have fraction raised to power a particular, a common power, the power can distribute over the fraction. That's why you have this. Also, this one can distribute over the fraction. That's why you have this. Then equals to 256 over 729. Now, I want to bring these 10 together. Those are similar. So I can write it as, since they are multiplying each other, because according to law of commutative, A times B is the same thing as B times A. So that means I can write this as 2n over 4n times 3n over 3n can be written this way. Then if I decide to write it this way, definitely I will have, what this one means is 2m over 2 raised to power 2n times 3 raised to power n over 3 raised to power n. Then I have this one as 256 over 729. Now, I can now write this one as 2 raised to power n over 2 raised to power 2n times 3 raised to power n over 3 raised to power n. Then I have this one as 256 over 729. Now, in this situation, by law of indices, I can write this one as 2m minus 2n. I can write this one as 2 raised to power m minus 2n times, this one can be written as 3 raised to power n minus n equals to, so I now want to find an expression for this in terms of 2 and 3. So 256, if you go by your 2 times 2 into 8 places, you have to, that means 256 is the same as 2 raised to power 8. So 2 raised to power 8 gives us 256. Then I have 729 is 3 raised to power 6. So 729 is equals to 3 raised to power 6. So in that case, then that means I can have a scenario like this: 2 raised to power m minus 2n times 3 raised to the power n minus m equals to 2 raised to the power 8 times 3 raised to the power minus 6. Remember, when this one comes up, that's why you're having minus 6. Then in that situation, this one can pair up with this, and this one can pair up with this. So in so doing, I will have 2 raised to the power m minus 2n equals to 2 raised to the power 8. Then by equating the base, this one cancels out. I have m minus 2n equals to 8. I can call this equation 1. Then I have 3n minus n equals to 3 raised to the power minus 6. Equating the base, this one can cancel out. I have n minus n equals to minus 6. This is equation 2. Now, so by solving this simultaneously, then I have combining them. So I have m minus 2n equals to 8, n minus m equals to minus 6. So let me interchange so that the position of m will be here, position of n will be here. So let me leave the natural one, which is equation 1, and let me now interchange this. So this will be m minus m rather plus n equals to minus 6. So having succeeded in doing this, then I can solve this simultaneously. Since you have, and by simultaneous equation, you eliminate one constant to get the other one. After you have not gotten the other one, then you can now substitute the value to get the second one. That is the concept of simultaneous equation, and that is what I want to apply. So in this scenario, I want to eliminate m. So the best way to eliminate m is by adding the equation. So m plus this, that one becomes 0, then this one will be